Hello and welcome. I'm Ruth Trundley, one of the team of writers behind No Nonsense Number Facts. In this short video, I want to consider how No Nonsense Number Facts can contribute to rebuilding mathematics communities. The reason we've called it Rebuilding Mathematics Communities is that we know that the impact of remote learning in mathematics due to the lockdowns has been significant in terms of mathematics communities and mathematical behaviours. One of the things we've observed is children who've been at home during the lockdowns have been much more reluctant to engage in mathematical behaviours when they're back in school. This includes talking about their mathematical thinking, sharing ideas, making connections using what they know, and collaborating with others in maths lessons. So we believe that focusing on increasing opportunities to both reason and share thinking will be vital to rebuilding mathematics communities. And in particular, developing oracy will be essential in re-establishing mathematical behaviours. So I think it's worth us considering what we mean by oracy. And this is taken from Voice 21's oracy benchmarks. So oracy has within it both speaking and listening. It's the ability to articulate ideas, develop understanding and engage with others through spoken language. And what we can see is that a high quality oracy education involves both learning through talk and learning to talk. And through this process, students develop and deepen their subject knowledge and understanding. This requires careful planning, designing, modelling, scaffolding and structuring by teachers. And this is exactly what we want to look at with No Nonsense Number Facts, how it supports this process. One of the things we know is the impact of a high quality oracy education has an impact on lots of levels, and this includes helping to narrow gaps and promote social equity. And one of the things we can see, the returning to school after the disruption we've had in the past year, we can see an opportunity to build equitable classrooms where all learners are able to participate and have the potential and the opportunity to be influential, and oracy is key to this. So within No Nonsense Number Facts, the activities provide time for pupils to discuss their mathematics, to rehearse their ideas in pairs and trios, and then share their thinking with the whole class. And oracy is supported throughout. Teachers are guided to support pupils to both talk and to develop their understanding of their mathematics through talk. An example of how oracy is supported within No Nonsense Number Facts is through the use of sentence starters, which you'll find throughout the materials. We tend to use very simple sentence starters. The four you can see on the screen are the most common ones used. Not only do they support pupils to talk, they support pupils to understand the sort of things we're interested in them talking about. So I know indicates that we're wanting children to connect the mathematics they're working on with things that they already know and making that connection using what they know in order to problem solve. I think we're interested in their mathematical thinking, and that's one of the things we want them to be able to share and to be able to build on. I notice, this is key to reasoning, noticing things, noticing in the mathematics. That's what allows you to connect to things that you already know. And I wonder, going beyond maybe the immediate situation sometimes and thinking beyond the solution to the current problem. So we use these sentence starters throughout the materials, and we'll look at a couple of examples from two of the year groups now. This example is taken from year 2, and you'll see the first thing we do in the session is to write the sentence starter on the board. We know that. In this case, it's we know that because the children are going to work in pairs and come to a decision together about what they want to communicate about their thinking. The picture is shown to the children, and we're going to think about the number of birds. So as the children look at the number of birds on each branch and they say how many there are, we write the numbers above each branch. So we record 9, 3, 7 and 1. And then we ask the question, which two numbers would it be easiest to add together first? Why? Can you and your partner explain using the sentence starter? So we're wanting to find the total of the number of birds altogether, but they're asked to think, which are they going to add together first and why? And our expectation is that children are going to notice things, Notice there's a 9 and 1 and they know that this makes 10. Or notice the 3 and 7 and know that 3 and 7 make 10. So that's the sort of thing that we would be looking for. And then the children will explain, we know that 9 add 1 equals 10. The session continues with the teacher choosing a pupil to explain the decision they made with their partner using the sentence starter, and then seeing if other children have made different decisions. And again, that prompt is there, that what you're looking for is that 3 and 7 and 1 and 9 are easy pairs to add together because they know that they equal 10. And then we have a further bit of mathematics for the children to consider. What's the total number of birds on the branches? Do you agree with your partner? Can you explain your thinking? So you'll see that the sentence starter has been there to support the children to use what they know in this situation where they're adding 4 numbers together, using what they know about pairs of numbers in order to make the addition easy. This second example is taken from Year 4. It's a number talk. The calculation is put on the board and the children are invited to work it out, making a decision about how they're going to do it and noticing that decision. You might like to work that out for yourself. So the teachers are guided to collect the different answers and write them on the board, and then choose pupils to explain how they chose to multiply the numbers. And when the children explain how they chose to multiply the numbers, the teacher's role is to record calculations to match their explanations. So the children are representing their thinking with language, and then the teacher is matching that with a representation of their thinking in symbols. We exemplify the sort of thing that might happen next, and what you'll notice is we have sentences that start with I know. So we're looking for this sort of sentence structure to be embedded now with the children. And we've also got very complete sentences and complete explanations being modelled within the text. So it helps the teachers to know the sort of thing that they're looking for. So this is Nancy's solution, and here's what the teacher writes. Then we go to another child. This is Isaac's solution, and this is what the teacher writes for Isaac. And by putting the pupil's name beside their method, it allows you to take the learning further and to have a discussion about what you notice about different methods. So that's what happens in this session. Two of the methods are chosen, and we suggest which ones. Choose one where somebody has multiplied 8 by 5 first and one where they did not. That's what we just had in the 2 examples. It's quite likely there will be children that work from left to right, and so they'll do 8 multiplied by 6 like Nancy did first. And we've got a question, what's the same and what's different about how Nancy worked it out and how Isaac worked it out? Can you and your partner explain what you notice? You may have noticed with the 2 examples we've just looked at that the activities included in No Nonsense Number Facts aim to support pupils in developing an expectation that they will reason about what's already known in order to work out what is unknown. So in the first example, they already know bonds for 10, using those to work out how many birds there are in total on the branches. And again, the children will know some of their multiplication facts, 6 multiplied by 3, 8 multiplied by 6, etc., and then use that in a context where we're multiplying 3 numbers together. So time and time again, the activities explicitly and repeatedly draw attention to the expectation that they'll be reasoning about what you already know in order to work out what's unknown. So pupils are asked to notice things and then make decisions based on what they've noticed and what they know, and their understanding of relationships in order to solve problems efficiently. And then they're asked to explain their thinking, represent their maths in different ways, interpret and create context for the mathematics, and link all of this to symbolic representations. So the suite of No Nonsense Number Facts materials were devised to provide teachers with a coherent progression for supporting fluency underpinned by reasoning. We took the elements of the national curriculum that focus on number facts that are sitting within number and the number system, additive reasoning and multiplicative reasoning, and have grouped those around key understandings in each year group. And in each year group, there are 6 half-termly blocks, and each of those blocks focuses on one overarching key understanding. The start of one year revises understanding from the previous year and then builds on this understanding throughout the year. And each half-termly block consists of 6 weeks, and each week is a sequence of 5 sessions. The organisation of the sessions is flexible, and it's intended that teachers will make decisions about which sessions they use and which weeks of sessions they use. There is a suggested order in each block for the 6 weeks, but that should be varied as required, weeks left out if not needed, etc. There is a sequence to the sessions within a week, and the learning does build across the week. So the suggestion is that you would keep them in that order, but you may not need to use every session. And you might find that the learning, the mathematical journey in a session actually has to run over more than one day, more than one session. So the time that needs to be spent on the mathematical journey in each activity is the time that is needed for pupils to understand the mathematics. And that's the important thing, is to build that understanding. The sessions written are intended to run for between 15 and 30 minutes. And again, there's flexibility about how you might choose to use those. So you might decide to have a standalone sequence of sessions focused on developing fluency that run in tandem with daily maths lessons. Some schools are thinking about having an extra 15 minutes a day dedicated to building fluency, and No Nonsense Number Facts would support this. But the sessions can also be used as part of daily maths lessons as warm-ups or cool-downs, really giving that focus to supporting oracy at the start of a lesson, at the end of the lesson, with the hope that we build that throughout the lesson. And they can also be used as a starting point for full mathematics lessons, again, really giving that focus on oracy and a focus on reasoning throughout. So I hope that's given you an idea about how No Nonsense Number Facts has a part to play in rebuilding mathematics communities. For more information, please head to the Rangery website. Thank you.